Hey guys, I thought I might do a tutorial today on subsurface scattering inside of Maya and how we can produce interesting and good results using subsurface scattering, and also get to know some of the technical aspects of it, not just pressing buttons and you guys not really knowing what those buttons do. So let's get into it. Subsurface scattering, for you guys that don't know, is essentially light hitting an object and some of it getting absorbed and bounced around. For example, like this candle, you can see how some of the light's been absorbed. It's bouncing around and scattering, and it produces this really nice effect, and that's what we're going to try and achieve in terms of subsurface scattering. So what we're going to do in this tutorial is essentially produce one or two examples here. So essentially what we're going to make is one of these using subsurface scattering. So you can see subsurface scattering here being used. So these are some I did earlier. So now in Maya, let's have a look at our scene. What I've essentially set up here is we have our dragon models, which we're going to apply these shaders to. And at the moment these two just have Lamberts on, and this one's got a I've already done a test earlier on. And we have 3 area lights here. This is our primary one, producing the main lights off, and then 2 fill lights. And this backlight here will help us see the subsurface scattering more evidently. Okay, and in terms of the lighting, I'm using a linear workflow, and it's got quadratic. The lights have quadratic, and I'm just using ray trace shadows. Very straightforward setup. Okay. Okay, so now let's go ahead and create our subsurface scattering effect. I'm going to be using the MISSS Fast Simple Maya shader. If you get this, I got this pop-up message because I've already got a few previous examples, and just use useless selected for now. I'll explain that maybe a little bit later. And this material is found just under Mentoray materials, and it's this one here, Fast Simple. And just remember that you need to be using have Mentoray as your primary renderer when you're using this shader. So let's firstly rename it to something we can remember, SSS tutorial, and then we're just going to assign that by middle clicking and dragging it onto the object. So now we've got the shader all ready to be used. Let's go do a quick test render just to see what the default render looks like. Okay, so the effect you can see already looks pretty convincing. We can already see some of that subsurface scattering effect appearing in the object. And now it's just a matter of adjusting our settings to get the effect, the desired effect that we want. So let's see how we can do that. The first thing I do is I always, before I do anything else, is set all the weights to 0. This is so that we can, the subsurface scattering shader is essentially broken into 3 sections. We have the diffuse layer, we have the front subsurface scattering layer, and we have the back subsurface scattering layer. we need to adjust each one of these separately to easily understand and get the best results. And we turned the weights down to 0 because the weight essentially is the amount of, I guess, how much each section or layer has on the overall subsurface effect. And it also makes it easier to visualize how each individual section affects the overall subsurface scatter. So now that everything's turned down to 0, let's start with our diffuse layer and understand what that does. So the diffuse layer, I guess this is essentially like having a Lambert shader. We can adjust color. First you need to turn up the diffuse weight to 1 to see the effects. So we can adjust the color, the ambience, and the overall color. I generally leave these at white, and I leave ambience at black, and generally I don't mess around with these settings too much because I feel that overall most of the settings can be adjusted using the subsurface scatter layers. But if you want the surface of your material to be a little bit more, have a bit more of a Lambert kind of feel to it, then by all means turn up the weight of the subsurface scatter. But for now I'm just going to leave it at 0. Now I'm going to turn up the weight of the front subsurface scatter. Let's see the effects of what the front surface scatter is. Now, front subsurface scatter and back subsurface scatter. Essentially, I guess this is a little diagram I've drawn up. The front, if this is our object here, light hits the object, and this is called the front subsurface layer, because it's the light that bounces back into the camera. Now the back layer is the light that passes through the object, and some of that information does return to the camera, but most of it just passes out the other end. That's how we get that translucent effect when it comes to subsurface scattering. So let's focus on achieving a nice front color. First we'll choose a color that we like, so let's go blue. And we'll make sure that our weight is 1, and the weight is how much the overall effect will be. Let's do a quick test render. We'll store this one. And we can start to see that we're getting an interesting effect already. Now, something I forgot to mention earlier is that the actual scale of the object is 10 centimeters, 10 mi units, and it's very important to know the scale of the object so that we can accurately reproduce the subsurface scattering. So, now that I know that the scale of the object is approximately 10 centimeters, and now this is very important so that we can control the front subsurface radius and the back subsurface radius. The front subsurface radius is how far the light can penetrate through the object. So at the moment it's passing 10 units to the objects, which is far too deep. I feel that, at most, depending on the scale of the object, this may need to only pass 1 or 2 centimeters or even half a centimeter. So let's bring this down to 2 units and then re-render and see the overall effect. Now this is a big improvement. We can start to see that the front subsurface layer some of that light is starting to penetrate the object, and it's giving an interesting result, but I think it's still too strong, so I'm going to bring down the radius a little bit more. So now it's going to be passing 0.7 of a unit through the surface. I'm quite happy with this result now. Now that I've finished adjusting the front SS weight, I'm going to turn the weight down to 0 so that it has no effect anymore, and I can start focusing on the back weight, radius and depth and colour. So let's choose an interesting colour, maybe purple. I think that will produce an interesting result. I'm going to turn the weight up to 1. Now remember, the radius is how far that light can penetrate through the object, and this is the back light. So let's see what the current result we get. So we're getting some of that interesting backlighting penetrating through the object, but it's far too strong. So, and remember, like we said about the radius being in the number of units, so if we just bring this down to the light penetrating of about 1 or 2 units, then we should be able to get a more, I guess, realistic result. So I've brought it down to 2 units, the radius down to 2 units. That's looking a little bit better. Now it's interesting to note that the back SF step is essentially used to clamp off the radius, so I generally leave this at 0, and that will essentially use the same value as the radius. What I mean by clamping is that if you have a radius of 4 centimeters, 4 units, and you have a depth of 2, then it's going to clamp it off at 2, and it's just a way of getting a little bit more control over the overall effect, but I generally leave the depth off. So let's bring this down to maybe 1 unit and see if we can get a slightly more better result. So I'm really happy with this result here, and I'm thinking it looks really good. You can see just a little bit of that backlighting is penetrating, and we're getting this nice effect. Now it's just a matter of combining the front weight and the back weight to produce the optimum results, and there's no real right or wrong here. It's just a matter of turning up the weights to whatever you feel will work best. So let's knock these both up to 1, and this starts combining the two, the front subsurface and the back subsurface together. So we can start to see that the front is the more dominant effect, while the back is not very evident, but you can start to see a little bit of that purples showing through, but it's mostly dominated by the blues. So I might turn the weight up to, for the back subsurface scattering, up to 2 or 3, and see if I can get more of that purple to show through into the subsurface scattering. I generally leave the weight generally around about 1, because if it's lower than that, then the actual colours seem to be a bit dark, but it's really just a matter of finding the best effect and what feels right. So I'm really happy with this. You can see some of those purples mixing with the blues, and it's producing a really nice result. So now that we've looked at what these values here can do, let's just go over a few other values of these settings here and how we can use them. So specular colour is pretty straightforward, how strong our specular is on the subsurface scatter. So if we turn it up, you can see it's going to make a sharper specular, and if we turn it down, it's going to make it more spread out. And that's pretty straightforward to explain. So I'm going to turn it up a bit, and then we're going to get a slightly sharper specular. we can definitely see there's a slight improvement. And then our shininess is, I guess, the overall intensity of the specular. And if I reduce it to say 10, it's going to start blurring the specular more. And if I increase it, I'm going to get a tighter specular. So let's reduce it down to maybe 20 and compare it. And that's looking pretty convincing. I'm really liking that effect, and it's looking really nice. Now that's our light map. This is the where the, I guess, the subsurface, the lighting information is plugged into, so we can get this effect. And the number of samples is the, I guess if you're getting graininess in your subsurface scattering, then you'll want to turn this up higher. I generally, you know, 64 is ample, but sometimes if there's a little bit of grain, then maybe turn it up to 108 or 256, and you might yield some better results if it's grainy. Coming back up to lightmap, if we just look at what's plugged in here, we've got our lightmap, and this contains all the lighting information that we need to produce the subsurface scattering. Okay. Scale conversion, I would generally leave this at 1, but if you're increasing the size of the object, then you need to increase it depending on the size of the actual object. So that way the light continues to pass through the object at the same scale. So if I double the size of the object, then I'm going to need to increase the scale conversion so that the light can only penetrate the same distance. The only other major, I guess, things we need to look at really is, I forgot to talk about the diffuse layer. So diffuse controls the amount of, I guess, how strong the Lambert effect is. So what I could do is increase the diffuse. Let's have a look at, so maybe 1, and you can see it's becoming more Lambert-like. So I generally, controlling it, you know, control it, increase the weight until you get something you're happy with. Add a bit of colour into it, and that will make that Lambert effect have a bit of colour in it. Oops. Let's see what that does. So the surface has become a little bit more matte-like, and you know, if that's the effect you're after, then by all means use it. But for this tutorial, I'm going to leave the diffuse weight to 0, so it's there's no Lambert, I guess, Lambert kind of material mixing with the subsurface scattering. It's going to stay glossy. Now, I might just have a quick look at the material a bit more, and if we look at the input and output connections, we have our shading group, but we also have this, if we look at our shading group and we look under the mental ray and we look at the light map itself, so under shading group, mental ray, custom shaders and light map shaders, there's these a few settings here that And the moment we just need to look at is this include indirect lighting. This means that final gather and global illumination will affect the subsurface scattering. For most of the time, leaving this ticked off will actually produce pretty good results, and you won't need final gather to affect the subsurface scattering. But if we turn it on, it will affect it, and it will increase render times a bit, but sometimes the results can look better, and the effect will be improved. So that's the main option we need to look at. So we can see that having final gather on and affecting the subsurface scattering, we can definitely see the subsurface scattering is more evident compared to when we didn't have it on. It's become more evident, and the light's bounced around quite a bit more. But it's really optimal and up to you what you feel is best, and whether you actually need final gather to affect the subsurface scattering. And we also can control the scatter bias. This is another one which essentially affects how much the scatter can affect the subsurface scattering. So if I knock, this is really a value range of 1 to -1. So if I turn this up to 0.5, so we can see that the backscatter is now passing more through the material. But I generally leave this at 0 and control these effects with the materials radius settings rather than that, but it's up to you how you want to control those settings. That pretty much sums up the basics of subsurface scattering, and I hope that's helped somewhat in, I guess, explaining some of the main features of subsurface scattering. And if this tutorial did help you, please feel free to subscribe and like the page. Thanks once again. Have a good day. Bye.